Hello, my name is Val. Today is the 10th day of my marathon where I solve leetcode problems and make videos. While doing so, hoping that somebody will watch them someday. Today is still a medium problem. We haven't got any hard problems this month yet. And the topic of the problem is again bitwise operations. The problem is called shortest subarray with or at least k, number 2. Number 1 is some other problem that we are not interested at the moment. We are given an array nums of non-negative integers and an integer k. An integer is an array is called special if the bitwise or of all of its elements is at least k. We need to return the length of the shortest special non-empty subarray, or return -1 if no special subarray exists. Now, subarray is a continuous non-empty sequence of elements within an array. It means that we cannot throw away elements. We select the left and we select the right and all numbers in between are part of that subarray. Now, what does this mean from human point of view? So basically, here we need to yeah, basically we need to select here, for example, as always, examples are not very helpful. So in this case, number 2 is 2, so we can return it. Here we can return 3 because or of those 3 elements gives us 11, which is more than 10. So yeah, let's try do something dummy. Let's see if we can solve this problem like this. So if we have an element that is greater or equal to k, we can return that element, or in this case, the length of subarray is going to be 1. It solves 2 of 3 test cases that we are given. Let's try to submit this solution. It obviously won't work, but we can estimate, okay, we solved almost 300 test cases from 700. So let's now continue and find a solution in general case. We will use technique called sliding window. Sliding window means that we define left end of the interval or beginning of the subarray right end or the end of the subarray, and we move elegantly through the whole array by either expanding the window or shortening it by one element. Moving through array, well, condition is like this. While both of the elements are within, actually I believe that we could have written it in a more strict way, but I'm lazy right now, so this should suffice. If it doesn't, we will come back and yeah. And we also have to maintain the current value of or bitwise for this window that we have. In the beginning window is just one number. This is the first element of the array, so obviously bitwise or is going to be that number as well. And here we do it like this. If bitwise or of window is less than k, we need to increase the interval. So make it like this. Otherwise, we should move left to the right, sorry, like this. This is very basic approach. Obviously, it's not going to work, right? Because we are not calculating the length of the shortest subarray. Let's get it here. Let's have it as a result variable, right? We haven't found any subarray that that meets the criteria, so we can store something very big here, like this, or actually that doesn't have to be that number. Let's look here. We have at least 100,000 of elements, so we can put 1 million here. Okay, so if we found interval that is satisfying the requirements, we can update the result. Result should be the minimum value between the result that we had before or the sliding window that we have right now. The length of the sliding window is right element, right index minus left index plus 1. That's it. Well, that's it in terms of calculating the result. Here, when we change the intervals of the sliding window, we need to maintain value of this variable. This variable is actually OR value for the whole subarray. It's very easy to update in this case. We need to apply a new element like this. But it's not, when we remove one element, it's not going to be that easy, right? Because we need to find a way to recalculate the OR for the whole subarray. And if we keep doing that many times, it's going to be bad because we may have a timeout. We don't have to. We need to find a smart way to maintain, to recalculate the OR value when we shift the left end of the sliding window to the right. In order to do that, we will maintain number of set bits for all the integers inside our window. In the beginning, since we start with first number, we will just have that first number bits, and we will also use the function from yesterday. It's called getBit. It just returns the bit array of the given number. This is what we start. Now, every time when we add a new number, we also will calculate its bits like this. And we will update the counter. Like this. Here, every time we are removing the element, we should reduce the counts. Like this. So we are throwing out left element, so we also need to recalculate OR. Well, now we can do it quite. Actually, I believe we can do it inside this. So we start with 0. If we have this bit set, we can add to OR corresponding power of 2. And here we could try to return the result. Let's see if it's going to fly or not. Okay, it doesn't. We return, and yeah, it means that we didn't. Okay. Something is not working here. Let's find out what is not. Yeah, the problem is that we are trying to, we are not factoring all the positions from counts array. Instead, we are factoring only the ones that we have set for this array. So let's not try to do these two jobs at once. Let's do it like this. First, we reduce the counter. Here, this we can throw away. and this will also. So basically, these are two mirror operations. Here we increase the numbers of set bits for the window. Here we decrease it, and here we are iterating through counts like this. And if the bit is, let's try it now. Okay, we still. I'm still missing something. Yeah, I think I found what is the problem. Here I made a typo. Yeah, let's try to submit this. Okay, we're returning 1 million instead of -1. What does it mean? It means that 1 million is this value, and we never got into this branch of the code because this array doesn't have a subarray that meets the criteria. So we need to return something, not 1 million here. So if result is 1 million, like this, then we return -1. Otherwise, we return result. Okay. Yeah, it's working. Thank you for watching. If you have any questions, please leave a comment. If you think that I'm doing something stupid, please also leave a comment. I will try to factor it into my next videos. I'm kidding, I won't, but feel free to post a comment anyway.